Dear friends, this is a very important and very interesting subject, that is refrigeration and air conditioning, which is very not important, but also essential. Initially, it was treated as a luxurious, but now it looks very essential as per the industry is concerned, as per the household is concerned, as per the transport is concerned. This refrigeration and air conditioning is very important. Initially, it was looking like a luxurious thing, but right now it is not luxurious. It is very important, and we should know about the air conditioning, and the demand of air conditioning refrigeration engineers is growing in India day by day. Initially, it was very demand for Middle East, but now in India, this air conditioning and refrigeration is becoming very essential. So we will talk about the refrigeration and air conditioning. Now, what is refrigeration and what is air conditioning? Refrigeration and air conditioning technology are used refrigerant to cool control temperature. What is this? Means we use a gas, a refrigerant. Now some with the mixture of chlorine and all called refrigerant 11, 12, some commercial name are there. That refrigerant is used in a machine which after some operation deliver cool air to the chamber, to the area, to the capsule. So this is air conditioning that is done through a refrigerant. Now remove the unwanted from substance, object, space, transfer. Now what happens? Suppose we are in this room, so we want to cool it to a certain temperature. Means in this room there is heat. That heat, with the help of using one machine, will throw it out to the atmosphere. Now what are the heat? Now we will have to understand what is heat. Heat and temperature. Suppose you are in a beaker, you take water inside and you heat it with a burner. So burner will give you heat energy, and that is recorded through a calorimeter. And the water status, how much it is warm or cool, it is done by temperature thermometer. That is give the state of water which is heating, and the thermometer gives the state, this 90 degree, 40 degree centigrade or Fahrenheit. This is the state of the water or the liquid which is heated through a gas that is giving heat by, and that is recorded by calorimeter. So this is the temperature and heat. Now there are two. If we consider the heat is energy, and it is taken as two types or two. One is sensible heat, another is latent heat. Latent heat is the heat when the substance takes to change its phase, that is latent heat. And sensible heat, when the temperature of the thermometer is increasing or decreasing, that is the concept of sensible heat. So these are the two heats. Suppose in this room there is some enthalpy. Now one is heat, another is enthalpy. What is enthalpy? Different from the heat. Heat is energy, but there is some another energy inside the air, that is the molecules of the air which is rolling out, so increase the internal energy. So latent heat, sensible heat and internal heat is called the enthalpy of the air. So in this room the air is there, so air has got some enthalpy. That enthalpy, with the help of machine, will throw it out to the outside in the atmosphere. That is, then we can cool down. Suppose outside is now 40 degrees centigrade. You need 24 degrees centigrade inside. So there is certain amount of heat. We will have to throw it out to the atmosphere with the help of some machine. That machine is called air conditioning, and this process is called air conditioning. Now another is refrigeration. Refrigerant, after certain temperature, if suppose we want to cool some substance below its freezing point, so that is called refrigeration. So in that case also, we cool down the heat from the substance and throw it out to the atmosphere. So these are the air conditioning and refrigeration. Now difference between air conditioning and refrigeration is the difference between air conditioning and refrigeration. That we will see later. Now you will see how we will do it. Now we have understand what is latent heat, what is sensible heat. Now how a machine operates when we use air conditioner. Simply a air conditioner, how it is. Suppose this is the place evaporator where you want to bring down the temperature, and this is your compression, this is your condenser, and this is your copper tube line, and this is your dryer, and this is and there is one expansion valve. These things are there. Now what happened? What we will do? We have got one compression, that is refrigerant compression. Inside there will be refrigerant 11 or 12 gas that is being compressed. Now say the refrigerant has one quality, that it can evaporate very soon and it can cool down, become liquid very soon. Now this compression compress the refrigerant which is coming from the evaporator. Evaporator is the place where you want to cool down. So this refrigerant is coming out with as a vapor and goes to the compression. Now compressor compress the liquid, temperature and pressure increase, and it becomes the vapor state. It becomes the supersaturated vapor state. Then it is sent to a condenser. Condenser may be water cooled, may be air cooled. Means if it is some air, here it is air cooled. Now some fan is there, who is throwing out the heat to this is atmosphere, warm air is going out. So this heat which is in the condenser thrown out to the atmosphere and it becomes liquid, and then it comes to a dryer. After that it comes to the expansion valve where it's throttled and become very cool, and then going as a liquid to the evaporator which is to be cooled, and that takes the heat from evaporator again going to the compressor. Now this is the basic circuit. Now you have to understand that you see here the cold liquid and cold liquid is coming, and which is taking the heat from evaporator, then going to the compressor, again it's cooled down, then become the liquid, and it's this way. Now you will say, why we need this compressor? Because why we need this? When it is cooling down, again heating down, why we need this compressor? It is very important question. Why we need it? Now you see, the heat taken from the evaporator by the liquid become gaseous, but its temperature is less than the atmosphere. So we need a compressor which increase the temperature from the atmosphere so that the condenser can throw the heat to the atmosphere which is lesser temperature than this condenser throw out heat. So heat can transmitted from condenser to the atmosphere. So we need the compressor because we have to increase the temperature both the atmosphere of the refrigerant so that heat can go out to the atmosphere. This is the basic thing of it. Now you see how it is. This is the evaporator. Suppose this is the evaporator in this room. So what will happen? This room, I will show you the real picture now. This is suppose a room air conditioner is there. This is, you see, a room air conditioner. This is a room air conditioner. I will show you. You can see it here from. This is a room air conditioner. You can see it. Now, suppose this room has to be cooled. Now, what will happen? Now, there is a compression. This compression, this is the compression. Compress the heat goes to the condenser. If suppose you kept the room air conditioner, this condenser is outside and cooling coil is inside. Cooling coil is inside. Now this cooling coil is with the help of a blower is with the help of a blower is sucking the air and coming in contact with the cooling coil, getting the heat, and this heat is through compressor going to the condenser and then coming to the evaporator. This way cycle going on. Now we will see. So this is whole about the air conditioning, basic thought of air conditioning. So this way we understand, suppose this is your room, this room is to be cooled. Suppose your ambient condition means atmospheric condition is 40 degree and you need 24 degree. It is seen that 24 degrees centigrade temperature and 55 to 65 relative humidity keeps ourselves pleasant, so standard we maintain it. So if suppose outside is 40 degrees centigrade, you need 24 degrees centigrade, we will use a machine that is air conditioning. This air conditioning machine will read in laboratory in next phase. So basically one compressor is there, one condenser is there, one fan is there, which is throwing out the heat of the condenser to the atmosphere. Then this tube line is coming, then this dryer is there which sucks the moisture of the refrigerant, and then this is going to the your expansion valve is cooled down and become liquid phase, and this liquid phase will take the heat from the evaporator and goes to the compressor. Same thing in a fridge. This is your deep freeze where the evaporator is. So this is the basic thing of air conditioning. Now for that we will understand two things. In which cycle it is? It is vapor compression cycle. It is vapor compression cycle. The vapor is compressed and expanded this way. This is the vapor compression cycle. You see, this is vapor compression cycle. This is also very important for you if you want to read this. This is enthalpy. I have told you what is enthalpy means: sensible heat, latent heat, and internal energy. This is in x-axis. And what is this? This is pressure. This is enthalpy and pressure. Now you see, we will see. This is the compressor air, superficial. Now this is evaporator. This is evaporator. And this is throttling process, mean expansion valve, and this is condensing valve. So what will happen? We will compress the air, goes to point 2, and this is the liquidus line, is going to the condenser. This portion is condenser, where it is cooled with the, it may be water cooled, it may be air cooled. This condenser throw out the heat of whatever the heat we have taken from the evaporator, that is thrown out to the atmosphere by this condenser. It becomes liquid, then expansion valve, then going to the evaporator. This is the whole circuit, and this is the pressure, and this is the enthalpy. So you can easily calculate how much enthalpy is there. Total enthalpy we have got this enthalpy. We will have to throw out this enthalpy to the atmosphere. Now this is the same thing, entropy and temperature. You see, this is the entropy. This energy, this we are through this condenser will throw out. This is all about these two things you must know: pressure and enthalpy, and temperature and enthalpy. This curve you must know. This is supersaturation condition. So this is the supernatural condition. Now type of AC system. One type of AC system, you have understand how the AC are or what are the components I have already told you. Now types of different type of air conditioning system. One is window air conditioning, which I have figure I have shown, split air conditioning and central air conditioning. Central air conditioning is generally done in a big complex or big building where air handling unit are there. That we will read in next part. What is the central air conditioning? So this is whole about my first lecture of air conditioning. Now we will see some other parts right now. Now in the next lecture we will discuss in another topic.